All right, so you've completed the Titan 1M. We're going to actually now modify it for our machine for the 770 so that we can run hopefully the part on Monday will be our goal. So I've made a test part just so I could go through the process, but here's what we're going to do. The first thing is we're going to do a file, save as, and we're going to call this 770M at the end of it. So we have a Tormach 770M. And that's what we're going to modify this part for. So we're going to leave a lot of this stuff. We're just going to change the tooling for it. So that's kind of the first step, is to import our tool library for the 770M. I have put that tool library on Google Classroom for you. So you should be able to import it, and it should look just like this. You have the tool holders. So these are TTS ER20 tool holders that we use, and then these are the end mills that we currently have in our system and what they're attached to. So that's what's going on here. We're going to primarily be using the 3/8 inch end mill. We're going to be using the number 21 drill, and then we're going to be using the chamfer. Those are the three tools we're going to be using. So we don't have a shell mill yet for our machine. That hopefully will be coming later this year, but as of this video, so we're using tool 2, tool 15, and tool 11 will be the ones that we'll be using for this. So the first thing we want to do is we want to change our facing operation. So we don't have this giant shell mill. And then, so we're going to select a different tool. So click on tool, go into the 770M library that you now have and pick your 3/8 inch end mill, hit select. Our machine runs up to 10,000 RPM. So 7,500 is fine. Probably going to run this at 9,500 RPM in real life. But for right now, this is fine. We'll leave it at 7,500 RPM for our purposes. We're going to run it at 30 inches per minute for our cutting, for lead in, lead out, and then for ramp, we'll do 15 inches per minute on this. Actually, I'm going to go ahead and change this to 9,500 for those. So go ahead and make that update. Our geometry is the same. Our heights are the same because, again, this is only 20 thousandths that we're taking off. Our pass is going to be a little bit different. So we don't need to go 1.7 inches outside, because if I hit OK, it's going to take passes like this. It's going to go across, it's going to come back, it's going to do it again, and do it again, and do it again. And we can kind of speed this process up by going in both directions. And then we don't have to extend 1.7 inches because we only have a 3/8 inch end mill. So I'm going to go in here with passes. I'm going to change this to 3/8 is 0.375. So I'm just going to do a 0.4. And then I'm actually going to do a 0.1 for stock offset. And the reason why I do a 0.1 stock offset is because not all the wood blocks that you have are going to be the same size that you machine. They should be within 50 thousandths, but I'm just going to go a little bit beyond that just in case. So that's why I do an offset of 0.1. Now, step over is automatic. Direction, we want to go both ways. You can see the conventional and climb milling. You can see that's exactly what we discussed today in class. We're going to go both ways on this. We're not doing multiple depths. We're not leaving any stock on the top. And then all the rest of this is fine. Vertical lead in, maximum stay down, all that's fine is what it was before. So now you can see that we go back and forth across that part to face it. So that's the first big change. Then we need to go into our adaptive. Again, we're going to change our tool. So this won't really change a whole lot. We're using that same 3/8 inch end mill. So you can go in here to the 3/8 inch end mill. If you want to put your spindle speed to 9,500, We'll leave all those. Geometry is the same. Heights are the same. Passes are the same. So this is all going to be the same stuff here. Optimal load is fine. If we were cutting aluminum, I'd probably take that optimal load down. But since it's wood, 0.1 is okay. And again, we're leaving 10 thousandths all the way around. We're going to do a 4-degree helix down into the pocket. We're going to say okay on that. So it's going to update. By the way, we are going to do another update on this when we actually get our stock. We're going to change the value of our stock in our setup. So in here, we would make sure that we have the appropriate numbers around the part. And typically what we do, instead of a relative size box, we would do a fixed size box. And then we can actually type in what the width, depth, and height values of my stock are. So my stock, might be 4.2, for example. The depth, which is the Y value, is going to be, it might be 2.05. We're 50 thousandths more than what we had done. And then we might be 1.025, 25 thousandths thicker than what we had originally said. We typically center the part in the X and Y, but in the Z, we don't want to center it because then we've got too much stock on top and not enough on the bottom. So on this one, we're going to offset from the top, and we would do a negative 0.02, 20 thousandths. So 0.02 offset. So we have 20 thousandths above our part, and then we have the stock below. And you can see here's our model dimensions. That didn't change, but we can do a fixed size box. And then we have to just rerun all of our stuff. And you can just right click, and then you can click on generate, and it will rerun all of your tool paths based on your updated stock. So we'll have to do that when we get our actual material. But let's just keep going through what we're adjusting. I wanted to show you that because that's how easy it is when you get your actual material. You just change the setup, put in your new dimensions, and you're good to go. We did our contour. No, we didn't do our contour yet. So we've done our adaptive. So double click on your contour. Again, I know that I didn't because I've got T2 for these, and this goes to T3, but that's the wrong tool 3. We still want tool 2 and our 770M library, so we're going to select that. Again, keep that at 9500. And all this should be the same. No difference there. Let's say okay. Going to go into our pocket. Again, double click on the icon, select our different tool. Here, 3/8. So I was wondering why I was showing all those tool things is because these are open. So I'm going to go ahead and close these out. I'm going to go back into that pocket because I didn't change this to 9500. So I'll change that. Geometries are all good. Just doing a quick check, make sure that we didn't miss anything in any of these settings. We're still plunging. That all looks good. This is kind of, oh, it just stayed down during that. Fine. That's fine. Stay down. That looks good. Chamfer time. So now we're going to pick a new tool. Again, this should be disabled. We don't have coolant on our machine. So here you can see here, we go to our chamfer tool for that one. I'm going to change the spindle speed to 9500 again. Ramp spindle speed, I'll keep that at 95. We'll go a little slower. We'll go 25 inches per minute on our chamfer, which is fine. All these should be good. These numbers look good. So we'll keep that. Oh, right here. This looks fine. If you pick, I saw this in a few students today. If you're here and you pick perpendicular, it's going to look kind of wonky when it comes in. So it does this kind of weird, tries to maintain this being perpendicular when it comes in. So I'm not a fan of that. I'd rather this not look wonky like that. So I'm going to just uncheck perpendicular. And it spreads those out a little bit as it goes in. Does its 45-degree transition and comes out of that. You can also pick a point. So it's kind of odd that it's like right here to start. It might have had to do with where I clicked when I did the original closed geometry. But you could also do a preferred lead-in position. So like if you wanted it to be on one of these transition points, might not be a bad idea like to start here to lead in, and then it will finish kind of at that point right there. So you can see how we kind of do that there. And the same thing, just it's the other side. You could pick, so for this backside one, you could also pick another lead-in point. So I've got one there, and I could pick one, right here if I wanted to see the one up top. Got those 2 points, and now it should do the inner one here and do the outer one right there. So you can see it come into the part. So those are options that you can do in the software there that I kind of like. All right, going to this one, again, new tool. Our library, tool 15. Again, update this, 9500, 500. Draw good. Geometries look good. Looks good. Remember, this is going to be a offset of 0.1. It's going to get your chamfer down a little bit further in there. Chamfer more of that off. That looks great. With our drill, this is our spot drilling with our chamfer. Back into our tool library. We have to go to milling so we can see that chamfer. Again, 9500 for my RPMs. This all looks good. Negative 0.105. It's great. That's all good. And then our last one is going to be our drill. This one I'm going to keep at a little bit slower speed on this one. It's our drill. I'm going to keep this at 4,000 RPM. I'm going to take my plunge feed rate down to 10 on this, just to slow it down a little bit. All this looks fine. Pecking depth and all that. It's good. And then we are not tapping with our machine. So I'm going to go ahead and just delete that tapping operation from our stuff. So that's operation 1. You can simulate it. Again, the simulations. Okay, so it doesn't like that I have different work coordinates because of the second operation is different than the first because I haven't updated it, but that was what the error was. We're still having simulation issues with the with that contour, I think. So here we go. Here's our facing operation. Again, it's a new operation because we have to go back and forth. Here's our 3D adaptive. So it looks good. Again, we're just walking through the process here, making sure that everything looks the way it should. This is probably about 2 times the speed what it's going to be in real life when it's doing this. All right, so see, there's that contour that's still messed up. So I think that's a fusion error. I put it on the forum to see if anyone else is having that error. My guess is they are. All right, there's the spots. Nice. Drill pecking there. Again, this is a drill chuck, so that's why it looks different than the TTS holder, because it is. So it's like from a drill press, using the same style of drill chuck for that. All right, and there's operation 1. It's going to operation 2, but we don't want to see that because we're not done with that yet. So let's go to operation 2. Call this OP2. Let's go into our setup, make sure we're good. So we're gonna see our part, flip it over. Again, we're gonna set it in like this. You can see that that's all correct. Our model box point is on this back corner there. That looks good. We're going to continue rest machining. Select on the plate. That all looks good. All right, facing operation. First things first. Different tool. Again, you can go into Op1. You can see the 3/8 inch end mill right there that we use. So literally we could go in there and just grab it from that. I'm going to change this to 9500. Geometry is our stock. Okay, our heights, this is fine. We're going to start at the stock top and end at the model top. So again, it knows what our stock height is because we adjusted that value. I'm not going to go 80 thousandths on my machine. I'm going to go 50 thousandths on our machine. Again, it's not an industrial machine like a Haas or a Dosan or any of those machines. I'm going to change my pass extension to 0.4. Stock offset, I'm going to keep it 0.1. And then direction, I'm going to go both ways on this. And all that looks good. So now we should have multiple step downs. And see, going back and forth. So this takes some time. You know, it's going to be much, once we get that shell mill, this will be 2 passes per step down. We'll get a 1.5 inch shell mill is what we're going to be purchasing. They're like $600. So we're saving up for that. I need to sell some more chargers. But yeah, this will get us to where we need to go. And then our last step is going to be that chamfer. Again, we're going to select our tool. We can just go back to Op1 and pull the same chamfer, adjust it to 9500, adjust our ramp spindle speed to 9500. So ramping spindle speed is when it ramps. So if it's, you know, following a contour like a trace, or if it's going into a part, that's what that spindle speed is. These are all good. Geometry's good. Heights are good. This all looks good. These look good. So we'll finish that. And there we go. We get our chamfer on that top edge. Now, all this looks solid. We want to check operation 2 and do a simulate. Operation 2. See what that's going to look like here. Back and forth, 50,000 step downs. 2 passes. 3. 4, and it's going to do a 10 thousandths at the end. So here's the next to last one, and here's the last final pass. There. Good. Our chamfer. And we're done. So that all worked great. I'm actually going to go back to Op1, simulate without the machine. See if this changes. Just curious. Speed this up. Yeah. Okay. So that worked fine. So weird. Let me now simulate with the machine. So weird. So yeah, it's the simulation with the machine is causing that issue. So I don't know if it's something with the post-process of using the Tormach or what the deal is, but everybody see that? So if I simulate, just simulate, and there's no machine, I run it, get to that spot, I'll actually just skip to next operation. So here we go. Here's the next one. So watch this. This will now cut the right contour path. And there it goes. You see it cuts the wall just fine. So weird. Don't know why that error exists. But we'll figure it out. So this is ready to go. So now here's our last two steps is we now need to create our G code. So we have an op1 and an op2. We're going to save these as two separate files. So we highlight op1, or you can actually hold down shift so that you have all of this operation right here. And you're going to click on this post process G1, G2. Here's our machine. It's going to Path Pilot. That's the name of the software we use. And then we can call this Titan 1M op1. I'm going to put my last name on it. And then I'm going to put this in an output folder that I usually have a flash drive. Let's see if it's in this flash drive. So you will need a flash drive for sure. I'm going to go ahead and browse. Look in here. And I'm going to click on new folder. Call it 770M programs. Select that folder. And then I'm going to hit post. Now save that. Great. Then I'm going to go to op2. I'm going to shift and do these. And I'm going to hit the same G1, G2. Call this Titan 1M op2. Wilkins. Same spot. Post. And it posted that code, and you can actually see your NC programs right here. And if you wanted to, you could rename these to op1, 2. And these are up to date. So if you change things, then you have to repost your code. But I now have my code on my flash drive. I'm going to go run this part on our CNC. Go ahead and save it. Once you get that done, take it over to the machine. I'll have a video on how to operate the machine, how to start it up, and put your code on there, and then run your part. So that's coming up next. Thanks, everybody.